Okay, Rafat. Now this is getting recorded. My entire screen is getting recorded, and you will be able to watch the video later on also. Okay. So I will continue. Can I continue, students? Okay. Okay. Now there is another problem that I want you all to see. Okay. Now this problem here, it says represent the following sentences using prolog system. Okay. The first sentence over here, it says Marcus, Mary, Clive and Caesar all were Pompeians. Okay. Fourth says Marcus and Mary were cheats. They were cheaters, right? Caesar was a king and Marcus and Mary were cheaters. Further, Clive was the minister in the court of Caesar. Then it says all, that is Mary, Marcus and Clive, all of them, they hated Caesar. Clive hated Caesar because Caesar was strict. Then Caesar had punished Marcus and Clive. Cheats are not loyal to kings. And finally it says a person kills another if he hates that person and that person had punished him and he is not loyal to that person. Now this is one of the favorite questions for practical exam. I don't write this question for your regular practicals. It could be a question that will come for the practical exam. Okay, I will just tell you how you can write this particular program. Okay, and it is telling you ask the following queries: who killed the Caesar? Okay, so one by one we will write these queries. Okay, so I will close this program. I'll create a new file on desktop and I will just say Marcus. I'll just name this file as Marcus. Okay, and now one by one we will represent the sentences. Students, remember I told you whenever in a sentence there is comma, for example here Marcus, comma, Mary, comma, Clive and Caesar were Pompeian. That means you have to represent this as individual sentences like this. So you will say Pompeian Marcus. Marcus was a Pompeian. Then Pompeian Clive, Pompeian Mary, and the fourth one Caesar. Okay, students, while always that particular predicate won't be highlighted with red, so that time you come to know that you have typed wrongly. Okay, so just observe the color codes as you write. So these four sentences, separate sentences, are for only this one sentence: Marcus, Mary, Clive and Caesar were all Pompeians. Next is all Pompeians were Romans. So in prologue, okay, how do you know what is the left hand side, what is the right hand side? Okay, so I told you already existing facts, they will come on the right hand side of the rule, and new facts which are to be inferred, they will come on the left hand side of the rule in prologue. So the new fact is Romans, because Romans is not present here. So I will say, if I know, okay, I will say new fact that X is Roman can be inferred if and only if the old fact that X is Pompeian is true. Okay, so this is the second sentence. Third is a direct sentence: Caesar was the king. So I'll write here King Caesar was a king. Then fourth sentence: Marcus and Mary were cheats. Okay, so cheat Marcus and second cheat Mary. Both were cheats. Okay, Now, Clive was the minister in the court of Caesar. Now, just ignore this court of Caesar. It was just given to confuse you all. So, basically, Clive was a minister of Caesar. That's the meaning of it. Okay. So, I'll write minister who? Clive is a minister of whom? Caesar. Okay. Clive was a minister of Caesar. And please see the spelling, it should be correct. Caesar, if I have written here also it should be Caesar. Okay, so Clive was a minister. Then further, all Mary, Marcus and Clive hated Caesar. Okay, all of them. So I'll say hate Mary, Caesar. Hate Marcus, Caesar, and finally hate. So Mary, Marcus, and finally Clive also hates Caesar. Okay, so all of them, all three of them, they hate Caesar. That's the meaning of it. Okay, so it is sentence number 6. All Mary, Marcus, and Clive hated Caesar. Okay. Further, Clive hated Caesar because Caesar was strict. Okay. So, since Caesar was strict, which is a new fact, okay, we can infer that Caesar is strict, okay, because a known fact that Clive hated Caesar. Okay, so this sentence is, we know that Clive hated Caesar, and Clive hated Caesar. This is a known fact. Okay, why he hated? So you can infer that the Caesar is strict. New fact on the left hand side and old fact on the right hand side. Clive hated Caesar because Caesar was strict. Caesar was strict. Okay, because Clive hated Caesar. He doesn't like strict people. Then Caesar had punished Marcus and Clive. Two sentences. So I'll say punished. Who had punished? Caesar had punished Marcus. So Caesar comes first. And Caesar had punished Marcus and Clive. Caesar had not punished Mary. It's not given, right? Caesar had punished Marcus and Clive. Cheats are not loyal to kings. That means a person is a cheat. Okay, so I can say that loyal to A comma B. So as it is when I write this sentence, it is like this. I can say that A is not loyal to B if and only if we already know that A is a cheat and B is the king. So this is actually the meaning of cheats are not loyal to kings. Okay, which means if A is a cheat and B is king, if this is known, then you can easily infer that that A is not loyal to B. But students, today also for practicals I mentioned that not is a predicate. Okay, and whenever you use not as the left hand side, okay, this marking here, yellow color marking, the prolog system tells you, makes you aware that this is a wrong usage of not. So not predicate always should come on the right hand side of the rule, not on the left hand side of the rule. Although the program will not give you error as such, but it might not give you the proper results. So whenever you want to use not predicate like this, you convert this sentence into contrapositive sentence. So I can write this in a reverse way. I can remove this not keyword from here. Okay. in a contrapositive way. I will say A, it is known that A is loyal to B if, okay, if A is not a cheat. I'll use not here. Okay, now the sentence actually is same. If you see the sentence, it is actually the same. What it says, A is loyal to B. You can infer that A is loyal to B if A is not a cheat and B is a king. Because if A is a cheat, cheats are not loyal to king. So the people who are not cheats, they are loyal to king. So I have this blue color says that not is a keyword and this is the correct placement of not. Okay, so this is how we can write cheats are not loyal to kings. Now last, it says a person kills another. So for good readability, I will just write here a person X. I will just say, okay, a person X kills another person Y. If he means who? If X hates that person means Y. Person X tries to kill another person Y. If that X hates Y and that person, who is that person? Y, had punished him means X, and this X is not loyal to that person who is Y. Okay, so if there is person X, there is person Y. X will try to kill Y. If X is not loyal, okay, if X hates Y, the first thing that I have given is if X hates Y and Y had punished X and X is not loyal to Y. Carefully see this. When X will attempt to kill Y, X will attempt to kill Y, it is given that if that X, he hates this Y, and just hate is not enough, and somewhere in the past that Y whom X hates, that Y had actually punished X, and X is also not loyal to Y. So this is the meaning of this sentence. So as it is, we will represent this sentence here. Okay, so I will say kills is a new predicate. Kills, who kills? Person A or X kills Y. When this happens, if and only if it is known okay, if X hates Y and means comma, punished, who had punished? Y had punished X and not loyal to. Who is not loyal to? So I'll say not, and within this I will write loyal to X is not loyal to Y. I close the bracket and press dot. Students, remember, if you write here hates, it will be a problem because you have already defined the hate predicate. So the same predicate you should write here. Here if you just write punish, it will give you a problem because you should write the same predicate that is already defined. Punished is defined, so you write punished. And similarly loyal to, you already have defined loyal to. Okay, so X kills Y if X hates Y and Y had punished X and X is not loyal to Y. So this is our code that we have written. So I will save this program. Okay, let's compile this program. So you will have to go to the shell here. Okay, and now let's ask some queries to this system. Okay, now what query is asked? Who killed Caesar? Who killed Caesar? Okay, that's a question. So kills. Okay, I'll just run this code again. Okay, I'll just compile this again. I'll say compile buffer, and I write kills who killed Caesar. Okay, now it says equal to Marcus. When you press semicolon, it's false. That means there is one person called as Marcus who killed Caesar definitely. And when I ask for an alternative, semicolon means give me alternate answer, it gives you false. That means there is nobody else who killed Caesar. It is Marcus only who killed the Caesar. Okay, so this is the first query. The second query that we need to ask the system is, was Clive not loyal to Caesar? Okay, was Clive not loyal to Caesar? So I'll just write not loyal to Clive, comma Caesar, and press dot. Okay, it gives you the answer as false. Was Clive not loyal to Caesar? False. That means Clive was loyal to Caesar. Okay, that means Clive was loyal to Caesar, because this sentence says it is only cheats who are not loyal to king. Although Mary and Marcus, both of them were cheats, Clive was not a cheat. So although Clive hated Caesar, he is not a cheat, and cheats are not loyal to king. So definitely your Clive is not is loyal to king, because he is not a cheat. Okay, so this is another program that usually we ask for practicals. Okay, you should understand the use of not predicate here. Okay, have you all understood this program? Anybody wants explanation for this program again? Quickly tell me. There are two major programs which are remaining. Okay, so quickly tell me fast. Say yes or no. Shwesh, can you hear me, Shwesh? Am I audible? Hello. Please type a message. Please type a message. I can't hear. Okay, my question is, you can hear me, but have you understood this program, Shwesh? Say yes or no. Have you understood this program, Shwesh? Just type yes or no. Okay. Is there anyone who wants wants to raise some query? Nishil, are you there? Nishil, have you understood? Nishil? Nishil is there? Okay, good. So I'll continue, right? Okay. So there are two major programs which we need to write. Okay. Now this program here will exhibit, how recursion happens in prolog. Okay, recursion is a very important concept for us to understand the medical diagnosis system. Okay, so what are we going to do? We are going to write a program. Okay, so we are going to write a program for login, for the login session. Okay, so without wasting time, let's write a new program. So file, new, and on my desktop I'll just create a new file called as login. Okay, now what this login program will do, I'll tell you. First thing, it will ask the user, it will ask the user to enter his username, Okay, and then he will ask the user to enter his password. Okay, now we will write another predicate called as user predicate. For example, let's say I want to store the username and password of two users. Okay, so for that I define user predicate. Please notice how I write this. User. Now the first user here is a John, okay, and the password of John, it's a whenever you write strings, strings should be written with single quotes and not the double quotes. Remember this. Whenever you are going to write strings, strings in prolog, they have to be written in single quotes and not double quotes. And after writing this, I press dot. This one predicate, user predicate, means in the prolog system you have registered a username called as John with its password called as ABC. Okay, so this is the first user which I have registered. Let's register another user. Second user, it's a LX, and whose password is XYZ. Let's say only two users are there. Okay, now how the program will start? So you are going to type log on. Okay, you are going to type a query called as log on and dot, and when this query is typed, okay, it's going to do the following thing. Just see. Okay, log on. First I will write the code and I will explain. Okay, let's do it level wise. I think you must have understood why I have written user. Okay, so by writing these two user predicates, I have defined two users and this is the password of those two users. If the username and password that you enter while logging in, it matches these two, only then login will be allowed, otherwise login will fail. Okay, so now next I need to get the data from the user, right? Get what data? Username and password. So I write another predicate called as get data predicate, and I pass two parameters for this. U is the username, P is the password. Okay, now how do you get the value of U and P? Okay, that we are going to write on the left hand side. So the very first thing is I will ask, on the computer screen it should be printed, enter the username, correct? So I will use a write predicate here and I will ask the user so this message will be printed on the computer screen, enter your user name. Okay, and to write the password. Okay, now this password should not be typed on the same line. You should the system should take you on the next prompt. So after after this message is printed on the computer screen, I will use a new line predicate so that whatever you write through the keyboard, that is entered on the new line, so it will look tidy. Okay, so you have been taken on the new line, so you will be typing through the keyboard the username, that is you. So I will use another predicate called as read predicate. Read you. Now what this predicate will do? So this message, enter your username, this message is it is printed on the computer screen, then it takes you on the new line. So then whatever username that you're going to type, okay, read predicate will read that username from the keyboard and it is going to store in the variable u, this variable u. Okay, now next message should come, enter your password, correct? So again new line predicate I will use so that it takes you to the, and now I will type on, I will use another write message. Okay, I'll say write enter your password. Okay, enter your password. So first it asks you to enter the username, it takes you on the new line, whatever you type from the keyboard, read predicate is going to read it and store it in variable u. Then it takes you to the new line, then write predicate will print second line on the computer screen and enter the password. Again I will go on the new line predicate, and whatever you type read predicate will read it into variable called as p for password. Okay, so you have done this, and finally this value of u, okay, and this value of p, that is username and password that user has entered. Now your system has to check whether that username and password matches this predicate or this predicate. So I will call the predicate here. I will say user in bracket u comma p, and now press dot. So what this line does, get data function basically, get data predicate basically finally will have the value of u and p, that is username and password. How it gets this value? First, it will ask the user to enter your username. Whatever you type from the keyboard, the username will be stored in the variable u. Then it asks you to enter the password. Whatever you type through the keyboard, read predicate will read it into variable p. So at this point, u and p, both the variables have got some values. Now you are calling user predicate and you are passing those u and p values. Okay, so here this thing will be true if it matches one of these already existing facts. And if this entire thing, the full thing is true, that means username password matches with this u and p. If this entire right hand side is true, it will in turn turn this get data true. Okay, so now I will write a top level predicate called as log. Okay, and now the very first thing that I am going to ask is, I am going to call this get data anything comma anything. Okay, I will first write and then I will tell you. You are going to write login successful and dot. See students, so logon is the topmost level of predicate. This is basically something like a start production. So whenever I am going to execute my code, what I am going to write, the query that I am going to fire is called as logon. Okay, the query that I am going to fire is logon. This logon query, in order to be true, the entire right hand side has to be true. Okay, so it goes to the first one here. So there is a get data predicate which is being called. So this has to be true. Now see students, I have written here underscore comma underscore. This underscore comma underscore can be read as first parameter can be anything and second parameter can be anything. So get data predicate is called. So from here the matching algorithm tries to match this get data with the existing rules or facts stored in the knowledge base. So the first match that is incurred is here. So here the first part will be u, the second part will be p. So it comes to this get data. Now for this thing to be true, its right hand side has to be true. So from here it goes to the right hand side. Then it will ask you to enter your username. You write your username, it will be stored in u. You write your password, it will be stored in p. Finally it is going to call the predicate user u comma p, where u is nothing but the username that you have typed, p is nothing but a password that you have typed. Okay, now assume that the username password that you have typed is John and ABC. So this will be user in bracket John comma ABC. So matching algorithm, for this to be true, it will try to match this with the existing predicates in the knowledge base, and you see user John comma ABC, this is already there. So this will turn this predicate also true. As a result, since all the predicates on the right hand side of this if and only if are true, okay, it will come in the reverse direction and it will say that get data u comma p is true. Okay, so this is true. Now since this is true, from where this was called? This get data was called from this get data function here. So as it goes back to the get data function, it has to actually carry this username and password to the get data function over here. But since we do not require the values of username and password, it is only enough to know that the login is successful, and we are not requiring to print the username and password later on, and that is why I have written here underscore comma underscore. which means whatever might be the values of username and password, the moment this becomes true, it will come back here, and then it will not record those username and password here. Rather, since this is true, it will go on the next line, and then to make this thing true, print a line that is login successful. Okay. Now, second thing. This last predicate, since u will not be equal to John or Alex, and since p will not be equal to ABC or XYZ, because I have entered a different value, this will become false. Now, since the last predicate becomes false, although all other predicates on the right hand side are true, this one false. It means the entire right hand side becomes false. And as it returns back to the left hand side, it returns with the negation. It returns false. So get data u comma p becomes false. Now, from where this get data was called? This get data was basically called from here. So in turn, this get data, it turns out to be false. If the username and password that you have entered, it does not match. Now, if this is false, then prolog system is not going to wait and go for other predicates which are connected with comma. Okay, it is simply going to return that false over here. So since get data has turned false, okay, it will do the reverse or backtracking, backward chaining, and this logon here, it turns out to be false. Okay. Whenever the login fails, there should be some appropriate message that should be printed on the computer screen. So what we will write is, if this is failed, we will write another logon. Okay, so we will write another logon. Okay, and here we will write all the failure related messages. So I'll say write. Okay, I will first tell the user that login has failed. Okay, I will first tell the user that the login has failed. Then I will take you on the new line. Okay, and then I should ask the user to log in again, correct? So it should be a loop. So I will say, I will write a message, please log in again. This message should be printed. And finally, so you are asking user to log in. So then again this logon should be called. So I call log on here. And log on, and on the right hand side also there is log on. Okay, I will save this program first. Then we will run and we will see what has happened. Okay, so I will save this program, save buffer. I will compile this program. Yes. Now, so the program has been compiled. Now what query you are going to fire? I am just going to say log on. That's it. Okay, I am going to say log on. See what happens now. And press dot and press enter. So now the prompt is asking me enter your username. Suppose my username is Amey. I press dot after typing the username and press enter. Now it is asking me to enter my password. So I enter any password, say X, Y, Z, and press dot and press enter again. So now the system says your login has failed. Please log in again. And it says enter your username. Okay, so this is the next attempt. Okay, if you want this to be printed on the new line, what you can do is you can just do one small change. Please log in here again. Here you can just type new line, so that it will take you on the new line. So I'll tell you what has happened. First, when you type log on, what has happened here is, okay, the query that is typed is log on. So for that logon query to be true, it should be matched with already existing logon predicate in the knowledge base. So it tries, matching algorithm tries to match, that logon. It tries to match this logon with this logon. It matches, right? But simply you cannot return true because it is left hand side. Left hand side can be returned as true only if all the elements on the right hand side are true. So the program takes you here. and here there is get data predicate. Now the matching algorithm tries to make get data true. Now for this to be true, it has to match this with an existing predicate in the knowledge base. So now this it tries to match with this data. Now this get data function here, okay, it takes u and p, two parameters u, but that's okay because here I am mentioning anything. That means this parameter its right hand side has to be 2, so it goes to the right hand side. Now it prints enter your username, and that's why you got the prompt over here. Okay, after logon you got the prompt here saying that enter your username. Okay, then it took you on the new line and then you typed Ame, which was printed here. Okay, so you see it first asks you to enter the username, it take you to the new line, then you typed Ame. So read predicate, it took that Ame, it printed on the screen, then you are taken on the new line, then you are asked to enter your password. Okay, again it took you to the new line and you entered the password also. Okay, so you see you have also entered the password. Just after entering the password and pressing dot, it says logging has failed. How this has happened, let's trace. Okay, so after you entered the password, it called user, okay, user predicate, where u was Ame and password was xyz. Now for this last thing to be true, this has to be matched with already existing in the knowledge base. Now user has a match here, user, but this Ame and this John, they don't match, so it's a failure. Then it tries to match this one with the second user predicate. There also this user which is Ame and this user which is Alex, they don't match. Since there are no more user predicates in the knowledge base, ultimately this turns out to be false. Now since this is false, the entire right hand side is false, which in turn turns this get data u comma p false. Now since this is false, from where this was called? This get data was actually called from this get data. So this entire thing turns out to be false. And now since this predicate has turned out to be false, the prolog system will not wait to check the next predicate. Rather, it will return failure to this logon. Okay, so logon ultimately has failed. Now students, remember the query that you fired here is logon. Now prolog system, what it does is it checks, okay, the first logon has failed. Is there any other predicate called as logon which can still make the query true? If not this, then which other? So then it notices that yes, there is another logon. The algorithm tries to match the query which is logon to the second here in the knowledge base called as logon. Now for this to be true, the right hand side has to be true. And as a result here it prints login has failed. And that is why it printed here login has failed. Further, after printing login has failed, it took you to the new line and it said please log in again. Okay, so this message here, please log in again. Now you see enter your username, this thing comes again. Now how this thing comes again? So this is basically recursion. Okay, so notice that after it tells you to please log in again, it takes you to the new line and it again calls this logon. And when this logon is called, the system, the matching algorithm tries to match this with already existing logon predicate in the knowledge base. Now this logon being the first one, from here the control passes to the first logon. Okay, so now the second iteration of the entire process that I explained will happen. So for this logon to be true, it will try to make this get data true. Now for this get data to be true, matching algorithm will try to match this one with the first get data. And again it tells you enter your username. And the same procedure will be repeated, and that is how the second prompt has come. Okay, so I will continue. So enter your username, I say Alex and press dot. Now it tells me to enter my password. Let me write the correct Alex, password is XYZ. Let me write the XYZ, the correct password, and press enter. Okay, wait, there is some mistake in my ALEX and XYZ. Okay, please enter your username. ALEX is a username and password is XYZ. Yes, it says login successful, and it returns true. Now how this login successful message was printed? Because second time I entered correct username password. I entered username as Alex, password was XYZ. So U was Alex, P was XYZ. So it came here. Match that was found. Now since this one matches with this one, the last predicate turns out to be true. As a result, the entire right hand side is true, which in turn makes this get data true. Now from where this get data was called? This get data was called from this topmost get data. Since this is true, this get data also is true, and now the prolog system goes in the forward direction, and then it prints login successful, and then there is a period. Okay, so I am not recursively called anything again in this particular login. So it simply prints login successful. Now by printing this two, the entire right hand side of logon has become true. As a result, it returns with success over here, and this logon is also true, and that is why the message that is printed here at the end is true. Okay, so this is an essential, very important program for all of you to understand the next and the last one, which is called as medical diagnosis system. I would like to ask you whether you all have understood this login program thoroughly. Have you understood this login program thoroughly? Just quickly type yes, 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 or no, no, no. Quick. All of you type yes or no. Okay. Yeah. Ronan Mendes. Yeah. Okay. Since it's already 9:48, okay, now the medical diagnosis system that we are going to see. Okay, I will not type the program here, rather I already have a program. Okay, and since you have understood this login, what I will do is I will explain you the program directly. Okay, so let's go to that program. I'll close this one and I'll say edit. Go to desktop, go to prolog programs, and I go to medical diagnosis and say okay. Okay, now basically what is medical diagnosis system? Okay, see, I'll just compile this. You ignore this particular warning. This is the warning, it had come previously also for another program. Whenever you get such warnings, right now you can ignore that. There is no problem. Okay, let's run this medical diagnosis system quickly. Okay, now the topmost predicate, the query that I will ask is go. Go is the query. So I will type here. Okay, 1 second. Compile buffer. Okay, there is some error in this, so best is I will type this query then. I will type the program. Okay, for your information, what is this medical diagnosis system doing? First of all, it is going to ask the user. Okay, we are considering few diseases in this case. For example, we will consider a disease called as measles. We'll consider a disease called as flu. We'll consider a disease called as chickenpox. Now, this medical diagnosis system that we are going to design, it is an expert system. What is an expert system? It's a AI based system that can do the work which any human expert does. For example, doctor is an expert. When you go to the doctor, okay, he will ask you what are your symptoms. Okay, as you tell your symptoms, okay, then he will have his hypothesis saying that since you have XYZ symptoms, I hypothesize that mostly you might be suffering from measles. Okay, so this is the hypothesis. Okay, so this is how the medical diagnosis system is going to work. Fine. Now So what are the things that we will require? First of all, we'll have to create the predicate for hypothesis. Okay. So let me create. Okay, for you I will create a new program. I'll say file new. New. On my desktop I'll save this as medical dot medical dg. Okay, so I'm going to write the program here. Now the very first thing that we are going to see, when in login system also, whatever are the lowest predicates, that you write first, then you design the next level higher predicates, and then you think about the topmost level predicate. This is how you need to write the program. Now the very first thing that you need to think about is the symptoms. What are the different symptoms? Okay, since I am going to talk about measles, flu and chickenpox, students, I will be taking the following symptoms. Okay, now if you are suffering from measles, basically the person gets fever, rash and cough. So I need to code this. So I will write a predicate called as hypothesis. Hypothesis that a person called as P, capital P, is suffering from, say, measles. Hypothesis that a person P is suffering from measles if and only if he has the following symptoms. If and only if, okay, the symptom that P has is, the first symptom is fever, and second symptom, one is fever, the second one is rash, for example. This is the second symptom, and third symptom, so for measles it is fever, rash and cough, for example. Say P is suffering from cough. So this is the first hypothesis. So doctor will say, or medical diagnosis system, your expert system will say that you are probably suffering from measles if the symptoms that you have told me are fever, rash and cough. So I have designed hypothesis predicate, and for individual symptoms I have written a symptom predicate. Okay, so this is the first hypothesis. Second, let's talk about flu. Okay, hypothesis that a person P, the same person suffering from flu, if the following symptoms are found. P has a symptom, let's say fever, comma, P has symptom, that is say headache, then P has symptom, for example, say cough, and last P has called as runny nose. Of course there are many, but let's take only this much. Okay, so hypothesis that the person P is suffering from flu if he has a symptom called as fever, headache, cough and runny nose. Now to kill the time, or to save the time, for example, I will be only considering two diseases. You can just go on adding many diseases here. Let's say our medical diagnosis system, it checks only these two diseases. Now let's write those individual symptom predicates, because user is going to answer that he is having a particular symptom. Okay, so write symptom predicate now. Symptom that person P has got, let's talk about fever. P has got fever is true if and only if. For that you need to ask the question, right? So you print on the computer screen, does, okay, does, so it will print on the computer screen, does, okay, then you print, because you need to print the patient name, so P, does P, again write, has fever. You are asking this question, does P has fever, question mark, and you are expecting user to answer this with yes or no, okay, comma, okay. Now new line, because user is going to answer this question by typing on the new line, and I'm going to read the reply that is given by the user. So I use a variable called as reply, and user will either type Y or N. Y means yes, he has got fever. N means no, he has not got fever. Okay, and finally I'll say reply equal to yes. I say capital Y because I have given it as capital Y. Okay, so first symptom, so it will print on the computer screen, does, it will take your name P, user, has fever, question mark, yes or no. Okay, whatever you type from the keyboard, read predicate will take it in the variable called as reply. And finally, you have fever if what you have typed is Y. So if reply variable contains Y, this final predicate will be also true. So when this becomes true, entire right hand side is true, which means the symptom that you have got a fever is true. Suppose you say no over here, after the question is asked, does person has fever, the moment you say N, no, that will be recorded in reply variable. Okay, since reply variable has no as input, the predicate here is fail, and since this is failing, your entire right hand fail. So this is for the fever. Similarly, the next symptom was rash, correct? So I will write the I can actually copy some predicates from the existing programs to save time. Let's do it. Okay, so fever we have seen. Similarly, second is rash. Okay, third is say runny nose. Fourth is cough. So I will just copy all this. Okay, so first we check whether the person has got fever. Next, we check that the person has rash. So does P has rash? The answer will be in reply variable. Okay, reply equal to yes. Okay, question mark is missing here. In fact, I will this fever thing also I will copy from here. Symptoms, does person has fever. Yes. So first, whether the person has fever. Second, whether the person has rash. Third is whether the person has the runny nose. The code is exactly same. Yes. And next is cough. What are the other symptoms? One is fever already written, rash we have written, cough we have written, fever, headache we have to write, headache, cough and okay. So headache we have to write. So let's write another predicate. Does the person has headache? And just copy this. And paste it here. So let's say these are the symptoms that we are looking out for. Now, after writing the symptoms, now the process should start. So first thing, get data function, it will take the data. Okay, it will ask you to enter your name. Okay, from there onwards. So I'll write this get data. Now this get data, okay, it will first ask you to enter your name. So I'll write predicate. It asks the patient to enter the name. Okay, then I take you to the new line. Okay, then whatever you type from the keyboard, let's say it is stored in variable called as p. So I'll use a read predicate for that, and it will be stored in p, variable p. Okay, next, now you know you are asking the user to enter the name. He has already entered the name. Now you have to check whether the person is suffering from measles or flu. So hypothesis has to be called. So I will call hypothesis. Hypothesis, and I am passing two parameters. P is the person name and D is the disease. Okay, so here after you enter the user's name, that is P, you are going to call hypothesis, pass this person patient name and D. So you are checking whether first for checking the measles and second for checking the flu, these two from here. Okay, and then based on whether this is true or false, the further part will be written. Okay, so then this is called as a cut predicate. Cut predicate is used to cut and no, it will not allow you to continue. I will tell you when it is used. New line. Okay, then it is going to write, it will write your name, patient P, then it will write probably has, patient P probably has disease, and it will write the disease name. Okay, D is the disease. Okay, so what will happen? Get data function, when it is called, first print on the screen, it will ask you to enter your name. Then whatever you type, that will be stored in P. Then it is going to call hypothesis P comma D. That means P is nothing but your username, and D will be the disease that will that you are trying to determine. Now matching algorithm will try to match this with the already existing facts in the knowledge base. So this hypothesis will be matched with the first hypothesis here, where P, this P is nothing but the username, and D, variable D, gets now the value called as measles. Okay, so we are checking whether the patient P is suffering from D, disease, which is measles. Now for this thing to be true, the right hand side should be true. So we check whether this the first predicate is true. Again, matching algorithm will try to make this true by matching this to existing predicate in the knowledge base. The first predicate is here. So symptom P comma fever matches symptom P comma fever, but this cannot be true unless the right hand side is true. So the first query that you are going to ask is, it is going to ask the user is, does, it's going to take your name, does Amay has fever? Please reply no. Then the last predicate over here, this will become true, reply equal to y, because reply stores y. So ultimately the symptom predicate happens to be true. That means you have fever. Now from where this was called? This was called from hypothesis rule. Okay, so this becomes true. Now only fever cannot be considered to judge that you have got measles. So then after this success it will go for the second symptom. Again, for this thing to be true, it will try to match this one with the existing predicate symptom, that P has rash. It will try to match the first one, not possible. Second one, yes, there is match, because here also there is rash, here also there is rash. P and P is same. So again it will ask you, does, it will take your name and say, does that particular patient has rash, yes or no? So then based on your reply, if you say no, then the last predicate here, reply equal to yes, will be false, which would ultimately turn the entire right hand side to be false. So symptom that P has got rash is false. This will become false. Now this was called from which place? Say this place. Now since this is false, it will not continue the process, rather it will report failure to the left hand side. Now since this hypothesis has failed, okay, from here the control will pass here. That means this has failed. Now the prolog system checks, if not this, then is there any other predicate in the knowledge base which can make this hypothesis still true? So it will try to match this with the second predicate here, hypothesis that P is suffering from flu. Now for this to be true, it will go to the right hand side. It will check for the symptom, and once all the symptoms are true, that means for every symptom that is asked, for the moment you press yes, 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 hypothesis finally will be successful. So this will return with success, and as it returns, it will return also the disease name, flu, that will be stored in D. And once this is true, it is going to write that patient P probably has disease D, for example flu. Now if it fails, many times it can happen that you may just go on rejecting all the symptoms, so that the medical diagnosis system is not able to diagnose you with measles as well as flu. Then what? So for that, another data function we are writing. Get data, and this get data we will just write, sorry we cannot diagnose your disease. Okay, I'll just write, sorry we cannot diagnose your disease, and you will go to the new line and say dot. Okay, so these are the get data functions. Now let's write the topmost predicate, the last thing. So how the program begins? Program begins when you type go on the computer screen. Okay, so topmost predicate is go. Now for this go to be true, its right hand side has to be true. First thing what you're going to say is repeat, because you're going to repeat the keyword, you're going to repeat this. Okay, and then you're going to call get data, get data function, get data. It's not get underscore data, it is get data. And then after calling get data function, if this get data is true, okay, then, or whether it is false, finally after diagnosing, the system should ask you, it should be menu driven program, so system should ask you again whether you want to continue or whether you want to quit. Okay, so whether it is get data is true or false, it will further print write, would you like to try again? Okay, and answer with yes or no. We're going to ask this user. Okay, whatever and then if the reply is yes on the similar lines, it's going to okay. So this repetition will happen until you say yes. Now when this reply becomes equal to no, that is a time when this go predicate will be false and the program will stop. So till this is yes, it will go on continuing. That's the meaning of it. Okay. There is some problem with the bracket here. Let's check. Symptom, okay, S capital, everything, S should be small. Yes, now it works. Okay, so I'll save the program. Now let's compile buffer. Ignore this warnings. Okay, and type data. Okay, suppose my username is say Ame. It will ask you, wait, I have not compiled it. Okay, I have not saved it. Okay, save buffer, and now you say compile buffer. Okay, so I type go. Okay, now it will work. I type go. It says login again, enter your. Actually, this login again happens to be from another program, right? There is some problem with the prolog. So let me reopen the prolog. I've discarded all the buffers. This may happen when you run in the same console multiple programs. Okay, so this was medical program. Yes, now I compile it and I say go dot. Okay, now it works. So it asks me to enter my username, say Ame. Press dot. It will ask, does Ame has fever, yes or no? Suppose I say yes. Okay, it said we cannot diagnose your disease because I typed small y, it should be capital Y. Okay, let's try again. So I want to continue, I want to try again. I say yes. Okay, enter your name, say Ame. Okay, let's type capital now. I have fever, I say yes, I have got fever. Does Ame has rash? I say yes, I have got rash. Then it asks, does Ame have cold? Yes, I have got cold. So then it says Ame probably has disease measles. Then it says, would you like to try again? Okay, suppose I say yes, I want to try again. Now further I type another name, say Amit and dot. Okay, now let's go on ignoring, let's go on rejecting all the symptoms of measles. Let's check. Okay, does Ame have fever? I say I don't have fever. No, capital N. Okay, does Ame has rash? I say no. So then it says we can't diagnose your disease. Would you like to try again? If I say yes. Okay, so this way the medical diagnosis system will go on diagnosing the diseases. Now at this point since it was, time was also short, it's already 10:15. Okay, I have done a very simple, I have taken only 2 diseases and very minimal symptoms. Okay, what you all can do is, for your practical on the file, you can add more symptoms. You can just search on the net what are the symptoms for a particular, for example, you can take chicken pox as a disease for hypothesis, and then we'll find out what are the symptoms for chicken pox. You can take some other, say migraine. Okay, say at least some 4 diseases you take. Similarly, the symptoms also will increase and the program will be more productive. Okay, so I think this is what I wanted to tell you, teach you regarding the prolog. Okay, so have you all understood medical diagnosis system? Okay, see students, now I will be sharing, okay, on I think Google, on your WhatsApp only, I'll be sharing one document. Okay, I'll tell you which document. So experiment I have done for you. You don't have to do anything. This prolog is hanged. Okay. Okay, so experiment number 8. Just check what I'll be sharing with you all. So I have reduced the effort. Now experiment number 8, its title will be expert system using swipe prolog. You can write as it is. Aim of the experiment will be to implement the expert system using swipe prolog. Now, in the theory part, what you are going to write? You are going to write about the swipe prolog software. That is, I just showed you edit option, new option, consult commands, how to create a new file, how to execute a prolog program, all this with snapshots. We can take a simple example with snapshots. You will have to show all this, okay, regarding swipe prolog. Then you talk about the basic constructs in prolog. We have seen comma. Comma means and operator or conjunction. Semicolon, which is or operator or disjunction. Not predicate. In your own words, okay. And finally, after writing this, you can write about what is expert system, and you can just briefly explain the architecture of the expert system. So this is all the theory that you have to write, and that is it. In the implementation part, you can simply copy paste all this. So in the implementation part, the first program that I have already done it today. The first program was that Marcus, that immortals inhabit heaven and all that. And you can see that I have written the program, I have written the problem, then I have written the program. So this is a snapshot of the program which is already run for you, and I have also shown you the output. Similarly, in the implementation, the second question is this cakes pickles that we discussed yesterday last time, okay, queries, and then this is the program for that, and this is the output for that. I have already done it for you. Third program was Alex, Peter are men, Jane, Ashley, Tina are woman, and all that program which we discussed. This is the program and this is the output. Both I have done for you. Then example is chocolates, toffees taste sweet, God tastes bitter. You just go through the example. This is the program that I have written and this is the output for you. And then the login session that I explained you, this is that program and this is the output for the login. And then finally the medical diagnosis that I discussed, the program that I wrote, this is the program, snapshot of that program, and this is the output. Okay, so all this you need to put in your implementation part. Okay, now students, I advise you, although you are copying pasting all this because there is shortage of time, I advise you, you already have got the software now, so you can see my examples and you can try practice yourself, because for practical exam I won't be coming and helping you. It is you who will be writing the program. And students, note the conclusion for this is basic hands-on programs on prolog followed by the medical diagnosis system using prolog were successfully implemented. So this entire document I am going to share with you. So your effort is very less. You have to only write the theory, and other things you can just copy paste from here. Okay? Is it okay? In one shot, just tell me whether it is okay. I have reduced your work. Okay, so should I now quit? I will share that document with you tomorrow, so that you have tomorrow and you have Saturday, Sunday also. Monday you can come with your files. Okay, Now what should be the date for the experiment? The date for the experiment will be the last week's date. Whenever you had practicals, whichever batch had practical, the date for the experiment, this last experiment, is the last week's date. Okay, that will be the date for your experiment. Also share the recordings, sir. Yes, I will share the recordings. Oh, it's a huge recording. Okay.